All right, now, we're going to come back to jet streams, but I want to talk a little bit about ocean currents. Because remember that wind is responsible for our ocean currents. In other words, the surface winds that blow in the world are responsible for ocean currents, for the most part, okay? So I'm not going to, this is just for you to go back and read to study for the test, but let's get to this one right here. I got to memorize all these ocean currents, but I want you to be aware of, maybe we should. It's a good idea. Anyway, I want to talk about two of them, all right? Let's talk first about this one over here. Now, we've talked about it before, but now you can really see it visually. You can see this is called the Gulf Stream current. The color coordinates the relative temperature. So red is warm, blue is cold. Look at this warm water, Gulf Stream water, that flows all the way up to Scandinavia. It actually keeps going up into northern Russia. So remember, this is that current that keeps everything so warm up here, all right? What causes it? This will be, what causes the Gulf Stream current? We talked about it, remember? What's that big weather system out here? My hand. My hand doesn't suffice as the proper answer. What would it be? What zone are we in here? You're in intertropical convergence zone. What's the next zone? Subtropical high pressure. And specifically, it's the Bermuda High that sits there with its clockwise circulation driving the Gulf Stream current. Okay? So that's responsible for this current over here. Now, let's take a look over here in the Pacific Ocean. Look at this interesting circular motion here. What weather system sits out there? Roughly that latitude. Who is the subtropical high's counterpart in the Pacific? Remember?
Tropical.
It's a Pacific high. Pacific high sits here. Clockwise circulation. Now, it took us a long time to figure that out. You know, how do you figure out this circulation? Okay, here's a good, this is lab number 7. Go prove that there is this, what we call the Great Pacific Gyre, you know, this clockwise circulation. How would you go about proving that, demonstrating?
You put something in the water and watch it follow the current.
Excellent. What would you put in the water?
Boat?
How about this? I got a really good one for you here. How about we take the Hansa carrier coming over from Korea full of tens of thousands of running shoes. What do you guys call them? Tennis shoes? And we'll sink it. All right, good idea. Let's do that. All right, let me take you to a website. Okay, so actually, back in 1990, this is what happened. The ship's leaving Japan full of running shoes. Bam, sinks. All these floating shoes are out in the Pacific Ocean. Here, I'll take you to this site here. Staying on top, I love it. I was there. Okay, this was a wonderful event. Well, it wasn't wonderful for the shoe manufacturer. Right? Okay, let me read a little bit here. Oh, it's not all going to show up. That's okay. Anyway, the ship goes down. These shoes washed ashore one at a time, but were wearable after a scrub down to remove barnacles, algae, and tar. All right, I found some. All right, look at what happened. They came out here and see these numbers. This is where the shoes started washing ashore, all along the British Columbia coast. Vancouver Island. I was living on Vancouver Island at the time, and we found thousands of shoes out there. You know what the challenge was? To find a match and the size fit, and not just a match size-wise, but model size. They weren't all the same style, right? There were, I guarantee you, thousands of people drove up from Victoria and were lying on the beaches here finding shoes. And anyway, so the point is, these shoes got dumped in around here. We started finding them here, found some in Hawaii. Anyway, and that's just one example of a spill. There was a spill of a hockey mitts. You know, have you ever heard about that one? Hockey mitts were spilled, and they float really nicely. And they made the same. Now, hockey mitts were of great excitement to Canadians as they arrived.
Well, you know that there was also a spill of yellow rubber duckies.
And there was a spill of yellow rubber duckies.
And subsequently, someone wrote a book about it called Moby Duck.
Yeah, that you can find all this stuff on the internet. It's pretty fun. But seriously, so you're right. You want to put something in the water and track it around, right? It takes a long time. Probably takes a couple of years, I would think. I think it was read to circle the Pacific Ocean. But anyway, that's one way we've been able to track the current there. Okay, this is an infrared picture of the Gulf Stream current I was talking about. I keep telling you how warm it is. Well, here's a visual for it. So remember, we've got the big Bermuda High sitting here, clockwise circulation, just driving that ocean current in this direction. It's color-coded to temperature, so your reds are going to be very warm temperature. These are going to be quite cold. But look at this tongue of warm water that just proceeds right up into Scandinavia, British Isles, Ireland, places like that. So that was the East Coast. Let's take a look at the West Coast of the United States. Now we have talked about this. Let me go over to the map here, just so you can remember. So remember, we got the Pacific High, we got the Bermuda High. They're both going clockwise. So just to review the Bermuda High, once again over here, clockwise circulation drives that really warm water up the East Coast. So when you swim off the East Coast, the water is very warm. Just the opposite out here. Pacific High, clockwise circulation, driving the current from the north down to the south. That's what you're seeing up on that slide there. Okay, so you think about this. What's going on is the surface water is being driven from the north down the west coast. But you might want to, I would ask, why is it so bloody cold right off of San Francisco? These are average surface water temperatures, 52.5 degrees. That's that's in the summertime. Okay, why is it so cold? Well, if we take a look at the next slide, it will help you understand that. We get something called upwelling of cold water. So you got the surface wind, this is the west coast of California. We got the surface wind coming across that moves the warm water off. It's removing the surface water, and so that's being replaced by deep water coming up. It's called upwelling. So and it's much colder now. Look at 52-degree water here is coming up to the surface right off the shore because it's replacing that surface water that's being blown away. So we call this upwelling. Now that's not the only place it occurs in the world, but it does occur off of our west coast, and that's yet another reason why the water is so cold when you go swimming off of San Francisco, LA, San Diego, places like that. It never really gets very warm.